Recording, there we go. All right, hello, my name is Eero Laaksonen. I'm the CEO of Valohai, and I'm gonna be showing you this demo webinar about Valohai. We're gonna start by talking just a few minutes about what Valohai is and why we build it. And then we're gonna concentrate mostly on the actual demo of the product. And then lastly, we're gonna spend a few minutes on talking about how to get your hands on Valohai and how to try it out if you're interested in looking into using Valohai in your daily life. If you have any questions at any point, feel free to use either the Q&A section or the chat. So you can stop me at any time. You can send questions at any time. I'm happy to do this as interactive as possible. There's quite a few of you, so let's make it interactive and let's cover all of your interesting questions. It's better for everybody like that. But let's get started. So Jacob is asking, will a recording be available? And the answer is yes, unless I say something obnoxiously stupid. And but even then, we probably can edit the recording. So yes, we are recording it. Okay. So let's get started. So Valohai is an MLOps platform. We are for companies that are building custom machine learning models. So if you're actually writing code, you have a team of data scientists, you have your own data, and you want to build a model for production use. Specifically, we are mostly focused on production facing teams that actually want to deliver value to companies via using machine learning. Some of the very common use cases that we see today are machine vision, audio, NLP use cases, a lot of deep learning, but also a healthy mix of classical machine learning in there too. So both deep learning and classical machine learning. There's also data pre-processing and all of the sort of preliminary work that goes into building a machine learning pipeline that we cover. And in that MLOps process, or that machine learning model building process, we cover two major parts. Those parts are exploration of models and then productionalization. And what we mean by exploration of models is when you're working in something like a notebook type environment, trying to figure out that first model that might be interesting, or later down the road if you're trying to iterate on existing models, trying to make them better, but doing exploration of both your data and new model types. And then when you've done with your exploration, actually want to deploy your models, we provide you a workflow and tooling that can do automated pipelines for retraining of models, and then also deployment of models, both for batch processing and also real-time online inference. And for those two areas, exploration and productionalization, we do two sort of major things. First of all, version control of all of it, including reproducibility of all of your exploratory work, but also your production work. And secondly, orchestration of compute, whether it's your cloud environment or your on-prem environment. We do all the orchestration, so you don't have to worry about any of your hardware infrastructure. So that's sort of the short explanation of what Valohai does. Then a few customer references today. We work in many industries, many different use cases. We are primarily a developer tool, so there's no specific industry that people are using us for, but some of our customer references you might know are Twitter, Lego, the toy company, JFrog, one of the famous infrastructure tooling companies for software development. And what I like to say, if we are the MLOps for the #1 DevOps company in the world, it's probably can't be that bad. So I really like that they're trusting us in this. that's it for the short introduction, and now we'll be going straight into the demo. So I'm gonna redo my share. There we go. Can somebody confirm me that you are seeing my screen? It should say hello and have this wavy hand. Where did my chat go? I just see that somebody sent me. Oh, there we go. Okay. Thanks, Ariel. Thanks, Yvonne. There we go. So this is the graphical user interface of Valohai. Something to keep in mind throughout this demo is that we are built API first. So everything that we're going to be doing here in the graphical user interface or our notebook extension, you can do via API calls. And that's one of the sort of major design principles that helps you get to more like robust production pipelining. But today we're going to be staying in the graphical user interfaces and not doing API work, but just to keep in mind. And I'm going to start by creating a project. And what a project for us means is a repository that contains all of your data, code, logs, metrics, models, prediction endpoints, everything that is sort of contained to the actual model that you're building, that stays inside the project repo. We have ownership management. If you're a startup, maybe not so interesting, but if you're a larger entity, you can integrate Valohai with your Active Directory, for instance, or any other SSO system, so that you can actually have granularity on who can access projects, who can access particular data, or training pipelines, who can execute parts of the pipeline, and so on. And in this demo, we're gonna start with the exploratory work, and we're gonna use our notebook integration to connect into this project. So here I have a locally running notebook. We also offer hosted notebooks, but I'm gonna show you the local notebook route. And on top of the regular Jupyter notebook, I've installed our extension. And this is a really easy to install one pip install extension that you can get running on top of your notebook. And in the extension, you have settings where I can select what project I'm working with, what the environment is going to be, where I'm going to be running. Today, I'm going to be running on Azure, but we also support all the other major clouds, AWS and Google Cloud, and you can also run on on-prem hardware. And once I've selected the project, I can run the notebook locally to sort of check my code, see that everything is working, maybe work with a small subset of data. But when I actually want to execute the whole notebook, I can click Create Execution. And what this will do is package my notebook, spin up a machine on the cloud, deploy a Docker image, and then ingest your code and data and start running it. So here we can see on the right that we have one execution running, and we can see all the log output in real time happening here. And once the execution is done, we can actually click on this and we can get the executed notebook back. And we can see all of our metrics and outputs, whatever we want to run. Let's say we wanted to try a few different hyperparameters at the same time. Valohai will take care of all of the sort of scaling up and work queue management for your tasks. So I can create an execution, I can change some parameter here, create another execution, again, change some parameter, create another execution. And all of these runs will actually go into a queue and then be executed when there's machines available. And whether there's machines available depends on your cloud quota and whether somebody else is running and so on and so on. So you have like super easy access to working on large scale compute, on large scale data on the cloud with your colleagues. So your colleagues are able to run on the same machines, and we will take care of all of the work queue management. So let's say you have a limited amount of machines and everybody wants to sort of run their notebooks on those. It's easy to do with this. You also get a sort of private version control. So what we noticed early on with the sort of data science workflow is that it doesn't really work that well with Git when you're doing this iterative real-time sort of working in notebooks. You don't want to commit every single time into Git to run your code. So we sort of came up with this sort of midway solution where we're saving all of these executions on Valohai. So you get this sort of private version control. So every single one of these executions is saved. So let's say you're in the morning, you have something that's quite interesting and you start iterating on it, and then you tweak it and tweak it and tweak it. And 8 hours later, nothing works. You have no idea where you came from. It's easy to jump back into that work. And this is one of the sort of major hassles that we saw in the day-to-day work. Second thing is sharing your work. So now anybody selecting this project in the extension who has access to it can see all of these executions and continue working on it. So it's like super easy for anybody to pull up this project and start working on it. They don't have to figure out like, where's the data coming from? What are the libraries that I need? And so on and so on. You can just come here, make changes, push it to Valohai and create a new execution, and it will be up and running. Lastly, if we go to Valohai side here, we will see that all of it has been saved to the Valohai project repo here. So if I now go and open any one of these notebook executions that we just ran, we can see all the details here. So I can see that this notebook execution was run on Azure. We used an ad hoc commit, which in our case means that it's not coming from a particular Git commit, but it's an ad hoc commit that was generated during execution, and we save the code. So if you ever want to go back and get the code, it does exist. You see the Docker image that was used, all the commands, the data inputs, what the parameters were, who did it, how long it took, what was the price. And if you're running on internal hardware, you can also set internal prices, so you can like figure out how much you're spending on internal projects and so on. We also save all the logs and whatever metadata you want to save from the run. So here, for instance, I have accuracy and loss function, and then whatever output artifacts you want to save from the execution, we can actually save to whatever your data backend is. So for instance, in this case, we're saving the actual notebook file, but then on top of that, we're saving the model file, and that can then be used later on wherever you want to. That's it for the exploration part. Now, if you have any questions on this, I'm happy to answer them. I'll give you 1 or 2 seconds and sip on my Coke. All right, nothing coming up so far. So feel free to ask anytime later on too. If you have anything, there's the Q&A thing on the bottom, or actually, I don't know how it looks for you, but I think that it's on the bottom where you can ask questions and I can see them. All right. So once you've sort of figured out your first model and want to start moving towards productionalization of your pipeline, what we do recommend is moving from notebooks into scripts that you save on Git repos. And here I have an example. So here I've taken the notebook and I've split it into a few different scripts, mainly preprocess.py. It takes in data, does some preprocessing, then saves data out. Then we have train.py, takes in data, trains a model, and then saves a model out. And something to keep in mind is that there's nothing Valohai specific in any of this code. It's all just generic Python. And by the way, you can also run R and whatever that runs on top of Docker in Valohai. It doesn't have to be Python. The way you integrate is not by like adding something complicated into your code. You just add a simple YAML file that defines the different steps of your pipeline. So if you're familiar with CI/CD systems, this is something quite similar. So here we have first the pre-processing step. We define a Docker image that can run your code. Then we define a command. And this is basically just a command that we're going to be running on the machine. This is just one line. We're running the preprocess.py script on the machine, nothing else. It could be more complicated. It could be many scripts. It could be unzipping a file, then running a script, whatever. And then data inputs for that particular step. And I'm going to be talking more about how the data actually flows in Valohai and how that works later on. So you will understand it. It might seem a little bit complicated here, but we're defining basically what the data inputs are that you want. Then here I have a training step. Again, we define a Docker image. Then we define a command. And then we have a placeholder for hyperparameters. So one of the things we do require you to do is if you want to do hyperparameter optimization, you need to take in hyperparameters as command line parameters. And then we define the different parameters. And keep in mind that this is completely dynamic. So you define your parameters that are significant for your particular model. So here I have epochs, learning rate, dropout, and batch size. And again, you define your hyperparameters. Then we have data inputs for the training step. And once we have something like this defined, we can take the repo. And by the way, something to keep in mind is that you don't have to have pre-processed data set and train model step. You can have whatever your pipeline looks like. This is a generic format where you can define a dynamic pipeline that fits your particular use case. It doesn't have to be these two steps. It can be something completely different, whatever your use case needs. But I'm gonna take the repository URL, go to the project that we created earlier, and now I can tie the repo into the project. And then I can fetch the repository. So now that Valohai has access to the repo, we can create executions from that repository. So I'm going to click create execution, and Valohai will decipher the YAML file, and we can select the different steps that we created. So these are the steps coming from the YAML file. There were others too. Then I just went through the pre-process and training, but there's a few others too. We're going to start with the pre-processed dataset step, and then we can select where to run it, and basically the rest of it is coming from the YAML file definition. And when I click create execution, we will spin up a machine, deploy a Docker image, ingest your code, ingest your data, and start running. So now it's running the code already on a machine on the cloud. And this will take 1 or 2 seconds. So if you have any questions, now is also a good time to ask them. Oh, wow. I'm being awfully clear today. No questions at all. Good. All right. So the execution is now done. Oh, yes. Yvonne is stating that the Docker images load very fast. That is true. And the reason for that is that we actually do a lot of caching on the background. So if we're running loads that use same images, we actually automatically, like if there's already a machine running, and that has a particular Docker image, then then the code will be deployed there. So it will be pretty much instantaneous to start the execution like you saw here. I just happened to have a machine already up and running that happened to have that Docker image. Then it immediately started. And the same thing will actually apply to data. So if we have, for instance, a hyperparameter optimization where you have 100 gigabytes or 300 gigabytes or even more data, we won't actually wipe the data from the machine in between. We will actually just destroy or reset the Docker image, but the mounting data folder will actually stay on the machine so that it doesn't have to take forever to load from S3 to your machine or then from like Azure Blob Storage to your machine. All right, now there's a lot of questions. Let's see, at least a few. Could you open up execution details? Do you need to configure resources such as max memory? Okay, so let's look at that a little bit. So the way you define is in the create execution view, we can select different environment types. So we are defining a particular instance type that we want it to run on. For instance, here we're running on a single GPU NVIDIA Tesla K80 machine, but you will sort of need to know what type of machine you want to run on. Here, for instance, we have an AWS machine with 8 CPU cores, 15 gigabytes of memory, 750 gigabytes of storage, 1 GPU, and so on. So you're not defining like, I want this much memory and this much GPU. You're defining a particular instance type for the execution. All right, that got answered. And then we have, I have a question. You mentioned the scripts are running on machines. Are you not running containers on a Kubernetes cluster? Yes, great question. Yes, we're not running the machines on a Kubernetes cluster. And there's a very in-depth reason, and we could talk about that for a really long time, but I'll just go through the sort of quick explanation. So our training runs are not running on Kubernetes clusters. Our deployments for inference are running on Kubernetes. And the reason for this is Kubernetes is primarily made for these single atomic, not very stateful, quick executions. So I'll give an example. Like Kubernetes was made for web services originally. So you have thousands of incoming requests that last for a few milliseconds, and then you're scaling up and down in that sort of environment. Whereas training tasks for machine learning are these very state-driven long tasks that can take hours or days or even weeks. And Kubernetes, while it does nowadays have a little bit of support for that, it's mainly just fighting against us if we want to run on top of Kubernetes. But right now it's starting to look like Kubernetes is going to that direction. So we will be adding a Kubernetes adapter for the training runs also during 2021. But right now we are integrating with the actual hypervisor. So whether it's like the actual AWS API, where we're using the AWS like actual native API or Azure native API or the native API for Google Cloud instead of Kubernetes in between. But for inference, which you will see later on, we do use Kubernetes. Then next answer, is Argo workflow engine involved in executing Docker images? No, we don't use Argo on the back end. It's all built by ourselves specifically for these use cases. Then next question is, can I use instance from AWS or Azure Marketplace? Does this mean that if you have your own AWS or Azure machine, can you use that to run executions? The answer is yes. So most of our installations are done in the customer cloud environments. where like all of your data and all of your code and all of your information stays in your environment. It never runs on us. You can also use our cloud machines like I'm doing here, but mostly our customers use their own machines. All right, that I think was all for the questions. Let's get back to the presentation. And by the way, if you have more questions, feel free to ask them at any time. So here we just ran the pre-processing step, and now I'm going to talk a little bit about the data. So what we do with data in Valohai is we take care of transferring your data onto the machine and out of the machine. And the way we do that is you can define files and they will be automatically saved to the machine and then made accessible for your code. So in this case, we are taking in test images, test labels, training images, training labels, and these will be on the machine in Valohai-inputs-test images folder. So now your code can access that folder and always have whatever the specified data was there. So it's easy to like run the same script, for instance, on a new data set if you want to. The same thing goes for outputs. So whatever we save from the execution that we run, you just write into a folder on the machine, which is Valohai-outputs, and that will automatically be saved to your data store. So in this case, we're saving the data for training, and that is automatically saved. Now I have an S3 backend configured here, so it's automatically saved to S3. And we build a data catalog on top of that. And I will explain more about what that means later on. But basically, here we've saved the data set from the execution by writing it into a folder. And then that is automatically saved by Valohai. And the benefit of this is that data scientists don't have to implement complicated S3 APIs or Azure Blob Storage APIs. They just read files and write files in their code, and all that complicated networking and transfer is done for them. And next, I'm going to use this data for training. So I'm going to start a new run, and I'm going to select the training step. And now, instead of the default values for the data, these are defined in the YAML file. Again, the data inputs are defined in the YAML file. And then, okay, there's a question. What if the data contains data subject to GDPR? How do you manage that? So a very complicated, in-depth question, but we have a lot of customers that have GDPR data. The simple answer is that usually when we're dealing with GDPR data, we install into customer environments, and their cloud already implements the GDPR requirements, and like the processes set in place in their organization take care of it. But what comes to sort of, there's a few interesting cases where you can use Valohai to implement certain requirements by GDPR. For instance, you get complete data traceability through your pipeline. So if you want to remove a particular file, it's easy because you have a data catalog and so on and so on. But primarily, we're not that like Valohai specifically is not like handling GDPR. It's mostly like what your processes that run on top of Valohai that handle GDPR. But there's a certain amount of like traceability and reproducibility requirements that come from GDPR that you can implement using Valohai. But that's a really, really in-depth and complicated subject. And if you have requirements around GDPR, happy to talk. We've dealt with that quite a lot. Okay, so now we're taking in the data from the previous execution. So we did the pre-processing, and now we're gonna go and search for in the data catalog for the data that we generated. So I can look for any data that was ever seen by Valohai. We're gonna or in this project. So I'm gonna look for the data, and I'm gonna take in the training images from execution number 6, which is the one that we just ran. So we're gonna be taking in data that we just generated. Then we're gonna take in training labels, test images, test labels. And again, this is completely dynamic. So you don't have to have training images, training labels, test images, test labels. This is something I often get asked, so I cover it. So you can have 100 different data inputs or just a single file, and the name can be whatever. It's defined in the YAML file. And now that I have all of this selected, I can, for the training, I can do some hyperparameter optimization. So you remember again, in the YAML file, we defined the hyperparameters. So now we can optimize them on Valohai. We support grid search, random search, and Bayesian optimization. And I'm going to do a simple grid search here. We can define for instance, a few different values we want to try. You can also do much more complicated stuff like define ranges for the Bayesian optimization and define functions for these values and so on. But I'm just going to do a simple example. So here we have a total of 27 combinations out of all of these value combinations. And when I click create task, Valohai will automatically spin up multiple machines and start running the code on that. So if you have code available and if you have defined that you can use more than a single machine, then we will do all the auto scaling for you and run the code on multiple machines at the same time. So here, for instance, now I have 5 machines running in parallel and the rest of them are in the queue waiting for the executions to go through and start up. And this can be configured according to whatever your requirements are. If you don't want 100 machines running up at the same time, you can use our admin UI to make limitations for particular projects and so on and so on. So you don't end up burning a lot of money by accident. You can also see metadata in real time from all of these executions. So here I've defined that I want to see accuracy from all the executions, so I can see all of those executions in a single view easily. I don't have to go around and pull all of my metrics from multiple runs and spend a lot of time doing that. I can just see all of it in one shot. The way you define these metrics that you want to see is quite simple. You just print to std out in this format. So a basic Python print command, and then this JSON format, and you can print whatever your particular metrics are that are interesting. And to keep in mind, this is not a replacement for something like TensorBoard. We also have support for TensorBoard, but this is mostly for like checking your most interesting metrics quickly. But there, you don't have to have just a single metric. You can have 100 different metrics and it will work just as fine. And again, we're saving outputs from this execution. So here we're taking saving the model and weights and biases of the particular model. Now, if we want to take the best performing model out of these executions that we run and then deploy it, we can easily list all of these details from the runs and then organize our work. So let's say I want to find now the model with the highest accuracy in this simple use case. I can see that looks like execution number 20 has the best accuracy. So I want to deploy that. And deployments for us means a REST endpoint that runs on a Kubernetes cluster. It's an auto-scaling REST endpoint that runs on Kubernetes. So I'm gonna take the output of this training run, the model file, and I'm gonna deploy that to a REST endpoint. The way it works is we create a deployment. We can select a cluster. So we support multiple clusters. So if you have multiple clusters, you can easily do that. And we create a deployment for that. And then we can create versions. So I'm gonna create a version. And now I'm going to talk a little bit more. I'm not going to go into the technical details of how this is done. You can check our tutorial videos and our documentation, or you can book a private demo. We can talk more about how the deployment works. But essentially in the YAML file, you define a file that exposes your model as a HTTP server or a VSGI server, and then we can deploy that on top of Kubernetes. So let's say you want to, a simple example would be you make a Flask server that exposes your model, and then that will work for us. And then you define that you want to take in a model file. You can also define multiple files, whatever your particular deployment needs. But we're gonna just need this one model file, and we're gonna look for the execution number 20 output model file. So now we're taking in the best performing model and deploying it into a REST endpoint, and it will be running in this endpoint in just a few minutes, or I should probably say seconds. So there we go, now it's running. One of the cool things that we've implemented is this alias function. And what that means is we can have stuff like testing endpoint and production endpoint. So now if you go ahead and call the root URL dash testing, it will point to this particular version of the model. And if you call dash production, it will point to this particular version of the model. In this case, we're pointing to the same version of the model. But now if a data scientist wants to deploy a new model for testing, they can go ahead and create a version. And let's say now I want to deploy the execution number 7, for instance, here, and create a version. Then we can go ahead and take the testing endpoint and point it to the new version and save changes. So now if you have a CI/CD or a QA pipeline that wants to test the model out before it goes into production, that can be done. And now again, going back to what I said in the very beginning of the demo, that everything we built is built API first. So normally in the long run, this would not be done manually by hand by data scientists. This would be done by API calls that handle the whole thing for you. And then if you want to do debugging or understand what's going on, you can come to the graphical user interface and like check what's going on. Maybe you have a problem going or something like that. And for that, we provide some pretty interesting tooling for debugging and understanding like what's wrong with your pipelines. So I talked earlier about the data catalog and data legacy that we provide. So let's say we want to take this endpoint and understand like where did this endpoint come from? We can click trace, and this trace works for every execution, every endpoint, any data set that ever has been in Valohai, and it will gather all of the relations of that particular entity inside Valohai. So here we have the predict digit endpoint that we just deployed. We can see that it's using the model.pb file that is coming from this execution number 20. That was one of the hyperparameter optimization runs that we did. Then that is coming from, or that is using data from execution number 6, which is the pre-processing run that we did. And you can see that that is being used by a whole bunch of different executions that are the different hyperparameter optimization ones. And let's say now if we had a problem somewhere in this pipeline and we wanted to go and debug, let's say maybe our data was broken and for some reason the training is crashing, we could just click here and we can go straight to the logs. We can see all the data inputs. We can download the outputs and check them out. We could also easily pull these into our notebook for further access. So let's say we wanted to use this data in a notebook and start like iterating like what's wrong with the data. We can take our internal datum URL. And this is getting a little bit complicated, but this is a really, really interesting way of working. You can pull it into the notebook here, and then start working on that data in a notebook and easily run that on the cloud and start understand like what's going wrong in my pipeline. So it's like now you're going from exploration into this productionalization and automation of pipelines. And then if at any point something breaks and you want to continue iterating on it, or if you just want to make a better model, a better performing model, or work on your pre-processing or whatever, you can easily go to any part of the production pipeline and pull it into your notebook and continue working and iterating on top of that. Lastly, I will show what we call pipelines. So here we've been independently running these different steps by hand, but that is quite cumbersome. So we also offer a way to combine all of this into a single pipeline. So in the YAML file, we can define relations to these steps so that we can create these complex pipelines that are completely defined by you. They can take any form. There can be multiple different pre-processing runs, for instance, that go into multiple different training or some sort of data augmentation or whatever your pipeline takes in, and then eventually come up with whatever the result is, whether it's a deployed model or whether it's some batch processing. You can build that into a pipeline. All right, there's a question. Can you detect if someone has manually changed an asset, essentially breaking your trace functionality? Yes. So first, I'll first tackle the first part. So we discourage people to manually go and touch the S3 buckets or Azure Blob Storage buckets that are running on the backend. So they are sort of machine controlled, and the way to access them is through Valohai. But if somebody goes in and manually gets access to the data sets and then breaks them, then yes, we do save so I can actually go and show. So if I go to the training run, we will have the checksums of all of these executions. And if you go and repeat this execution, it will actually alert you if the checksums have changed. So you will see if somebody has changed the data. Yep, we do track that. All right, now going back to the pipelines. So like I said, you can define a pipeline that can be run in a single go. So here I've defined a pipeline that has pre-processing, and then that data will go to 3 different training steps, and then there's an evaluation step for each of those, and then a script that selects the best performing model and then deploys that to an endpoint. So we're going to deploy the same endpoint that we created, and we're going to deploy to the testing alias in that endpoint. And when I click create pipeline, what this will do is first start the pre-processing, and all of that will be automatically saved just like before. And once the pre-processing is done, it will start the training, and so on and so on. And again, like I said earlier, everything can be done through API calls. So if we wanted to run this particular API, particular pipeline through API, it's really easy. We of course have an API documentation, but we can also just go and copy paste this from the UI. So it's like we made it as easy as possible. All right, then there's another question. Vera asks, is the intermediate data stored or recreated? So in this case, if we let me try and understand that. Is the intermediate data stored or recreated? So every time you run a full pipeline, the intermediate data is saved and stored into your data store. Then you can take that. If you don't want to run your pre-processing every time, you can go and take that and run the rest of the pipeline without that. without that pre-processing step, and use that. Like we use the single data set in the hyperparameter optimization. You saw the single data set was used by multiple different runs. So you don't have to always recreate it, but the intermediate data is saved and can be used anytime down the line. I hope that answered the question. If you have any further questions about that, happy to answer. Then there's another question. Can you do gradual deployments and schedule management? I'm sorry, I don't understand the question about the gradual deployments and schedule management. Can you elaborate maybe on that? What does gradual deployment mean? Can you deploy one AZ at a time? Okay. So yes, that depends on how. Okay, yeah. All right. So if you have multiple multiple zones, I would recommend, like, they would probably then be in different Kubernetes clusters, or then different different aliases, for instance. So there's multiple ways to go at that, and it depends on a little bit about, like, if you have, like, what the sort of scope and complexity of your whole system is. Then yes, you can do that by like splitting it up into, for instance, here. We could do an alias for like zone A, zone B, and then deploy to those, and so to mitigate the risk. I hope that answers your question. All right, we are running a little bit short on time. I'm happy to continue conversation over email, but I want to spend just a few last minutes to cover a few things. And then if we have time, I can answer more questions after that. But let me quickly switch over back to my other screen. There we go. So lastly, I want to cover quickly, like, if you are interested in Valohai, the way you can get started is we offer a 30-day POC for all of our potential clients, and that the way it goes is we offer the POC for your project in your environment without any cost or commitment. So what that means is you can get your existing machine learning project running in your cloud or on-prem environment, and it doesn't cost you anything, and there's no commitment. The way it goes is we do a scoping and setup to get it installed into your environment, and then the day one of the POC is onboarding that contains the technical onboarding for users. So we go through our manuals and an onboarding process, and if you are able to deliver us a project that you have already on, let's say, Git or something, we will give you instructions on how that would be converted to run on top of Valohai. So by the day of one, you have actually Valohai running in your environment with your project, so that you can just start working on it. And then we define success metrics on, like, what do you want to achieve during this POC. And then during the POC, we offer our normal support, which is an ongoing support that contains weekly catch-up calls with our clients. So we look into, like, how they're progressing, if they're running into any kind of roadblocks, if there's any ideas that we have, how to do things faster, how to do things better. And then we also offer ad hoc support over email and Slack. At day 15, we usually work together to build a proposal that gives you a fixed price that you understand, like how the pricing for Valohai goes, and you have sort of 2 weeks to think whether that makes sense for you or not. And then by day 30, we go into signing a contract, or if you feel like Valohai is not for you, then there's no commitment or any kind of cost. You're free to go and continue working the way you were working before. So it's a really easy, free way to try out Valohai. What we do require is that you have an existing project that you're already going to be running on Valohai. So that's sort of, we've seen more better traction with companies that actually already are in sort of really close or already at production scale with machine learning. So that's usually where companies start to get value out of Valohai. Quickly on like the implementation and onboarding for Valohai goes, depending on what kind of environment we're deploying to. If it's a shared Valohai cloud, so like I was showing here, that you're using our AWS machines or our Azure machines or our Google Cloud machines, then it's like super easy, very, very, very quick to do. If it's your private cloud, so you want Valohai in your AWS or your Google Cloud or your Azure, then it's usually about 2 hours for us to do the technical work. And then if it's on-prem, our average is 2 days, but your mileage may vary depending on how complicated your environment is. On top of that, there's usually about 1 day of training and project migration work that we do together to help you get started with Valohai. So this is the sort of time frame and commitment to get started with Valohai. That's it for the presentation today. Thank you very much for attending, and we have a few minutes left for questions, so happy to answer anything that you might have. I've lost my windows, just a second. There we go. That's the. So, okay. So there was a question about canary deployments. Well, I covered it partially, but I could quickly mention that yes, you can do like a load balancer in front, and then multiple aliases where a single one of them would be deployed to, and then you can push like 10% of your traffic into that endpoint. So that's the way you can do that. What's the largest infrastructure you've supported? Number of hosts? On the top of my head, we're talking. We're talking at least like hundreds of machines simultaneously. Whether it's thousands of machines simultaneously, I'm not sure, but like 1,000 plus at least simultaneous hosts running. Any more questions? Thank you, Lauri. All right, there's another question about. So Jacob asks if we have experience with edge deployments. The answer is yes. The way you would do edge deployments is you can have a training pipeline, but then like you can pull that model that you want from the API and then deploy into your edge. There's not much we can do in that environment because like those environments are quite individual for each user. But what what we have seen is like the training pipelines, and then if it's we've seen some do like complex deep learning on edge devices, and then you usually have like a big optimization run for the model, and then once that model is optimized, then you can go from there into deployment on the edge devices. Then we have a question: do you support partial onboarding where the example data preprocessing model training is running on Valohai and inference will be using customer-specific environments and vice versa? Yes, we do. So we have, for instance, clients that are using their own training environment, and then they are using us for deployment, our Kubernetes for deployment, where like the data that they are using for training cannot leave their systems, but then they don't want to host their own Kubernetes, so they deploy to our environment, and then maybe the inference data is not so critical. And vice versa also, like they have some already existing large Kubernetes cluster, but they want to do the training in our system and then deploy to their Kubernetes cluster. Both are very much doable, yes. All right, then there is a few others here. Let's see. How do you compare to Kubeflow? That's a great question. There's always a question about like the first easy thing to say is that that we are managed, so you don't need a team for running Valohai. You just buy the license, and we make sure everything works. Secondly, we do have a pretty in-depth look into Valohai versus Kubeflow. You can find that on our website. It's a sort of a quick ebook that compares the differences. I'd rather you probably will get a better answer by looking into that and actually looking deeper into that rather than me spending 1 or 2 minutes here trying to answer that. It's quite a big question, but yeah, we do have a book on it. All right, we are coming to the end of our time. I still have a few minutes. Okay, all right, there's a few more questions. I'll answer them, and then we'll have to close down the webinar. All right, there's a question. We're thinking about how to handle drift in data while the model is running. You mean probably referring to inference? Yes, we are shipping our first beta of our model monitoring that can handle like model drift and basic model monitoring in inference and production during end of year. So we'll have the alpha for our existing customers before end of year, and then it will be accessible for everybody during Q1. Whether it's like January, February, March, I can't promise yet. Depends on how the alpha and beta stage goes with our existing customers. But yes, we are shipping model monitoring during Q1. Okay, hey, that's it. Thank you. If you want to reach out or want to talk more about Valohai, you can reach out to me, eero@valohai.com, or book a demo on the website, or reach out to any of our emails or any of our channels. We're happy to talk more about MLOps. Thank you so much for joining. Have a good one.